All right, if you watched my previous video on this part, this landing gear strut thing, I showed this machine work of boring these holes in this part, but I kind of went over it very quickly. I didn't show any detail. I just said, you know, after I ran the boring head so many times to get it out to size. And I thought it might be worth it to make a video just on the actual boring here of these holes, because I have a procedure that I kind of go through every time when I'm boring this close to tolerance. Oh, by the way, the tolerance on the hole is 0.5934 to 0.5941, and the nominal is 0.5937 is what I've set my gauge, the dial bore gauge and the gauge blocks to set this up. Now what I normally do is, you really can't just run this thing, you know, set the boring head and run it, because there's just too many variables that come into play here. The way the tool seats in the spindle, the material can even make a difference, and things like that, and how much is coming off the hole. If you just run the tool, it may not cut to size, even though the last part you had it set to cut to size. It doesn't work this way. You know, even on a CNC machine, you know, if you're running a manual machine, you would naturally back the head off, and that's what I'm going to do here as well. But you just can't run a boring head and cut to this close to tolerance, just cut it the one time. It just doesn't really work that way. You could probably do that if you set up if you had a lot of little parts and you set it up and you ran the boring head and you said, okay, I took one cut after I drilled the hole and it came out to that size, and then you adjusted and you got it to cut, and then you ran the next part and you saw what it actually cut on one cut, and fiddled around with the setting until you got it to cut on one cut for every part. Possibly you could do that, but normally the tool doesn't make up in the spindle that perfect. You know, it does pretty good with this Capto spindle because it has a face contact and a taper contact. But it's been my experience, like on Cat 50, Cat 40 tapers that just are a single taper contact, that the tool may not repeat every time that way. And if you got a shaving or something in the spindle, of course, it could throw everything out of whack. And for these parts here, you know, I don't want to chance an expensive part and just run that tool and hope that I'm there. So this is my procedure and what I do. So normally on the ITS head, oh by the way, this is a ITS head, which this ISCAR sells this, but it's actually a rebranded D'Andrea boring head is what it really is. And this is their bar, but this is a heavy metal bar here. That because of the extension I have, I've got to go through this distance here, and this is what I had that would reach through that hole and not run into the end of the part with the tool holder over here and everything. This is what worked out for me. So, like I said, what I normally do is I back this boring head off. So I just loosen the clamp screw here, and I'll go 2 revolutions, 1, 2, and then a little bit more, and come back to it to take out any kind of possible backlash in the boring head. Now, and then just snug this clamp screw up. You don't want to use a big Allen wrench and really tighten down on this head. In fact, in the manual on it, it says not to do that. So they have this wrench, and this is what you use, and that's all you do is tighten it like that. Now, how I got up to this point, I should have explained that before I started all this. I ran the tool in single block down to here and let it stop in single block. Now, I could have put a program stop to do that, but the reason I don't put a program stop is because it's going to stop every time you rerun the head right there, and I don't really want to do that. So what I do is I watch this tool come in and I let it come down in single block and stop it right here, and then I open the doors, shut the spindle off and open the doors and everything. Now that we got our board head backed off the 2 revolutions, which is 4/1000ths of an inch per revolution on this particular ITS head, I want to explain something in the program itself, because this is going to be important when we run the tool. So before we run the tool, let me explain that, and I'll show you what I mean. Here is the program. What we're dealing with, the boring cycle, which is actually down here. I've kind of backed up in the program in the what they call the EIA monitor on this machine, so that you can see here. So end sequence number 4 is where the tool starts. Now, I don't normally put end sequence numbers in my programs except where I need them. So in this case, I put them at the start of every tool. So this is actually the 4th tool that's running in this program, and it starts on N4. So that's the way I have the post processor on for my machine works, the end sequence numbers. I don't see the need to have them on every line. I only put them where I need them. So in this case, remember this, we're starting on end sequence number 4. So we run the boring cycle, G85, so on. Sometimes I run a bore orient cycle, but on this part I'm running this, which is feeding in and feeding back out on a G85 at this feed rate. And then it cancels the cycle. G80 is a cancel of a like a can cycle, if you will. And the M9 is turn the coolant off, and then it goes to Y minus 6 inches just to move the tool out of the way so that I can get the gauge in there. And then it's a program stop, MOO. Now we have this statement with a block delete in front of it. Now this machine has 9 block deletes, so I can put a number after the block delete, or some controls call this a block skip. But the / is just a block skip, and it would do that even on this control with no number, but I can actually specify a number because there's 9 of them. And so if I have the number 1 block skip button pushed, it will see this one. Otherwise, it'll skip by it without even seeing it. So a block skip or delete, block delete, and then a go to number 4, which is up here, number 4 in the program. Now it'll be caught in this continuous loop, this program will, until I actually push this block delete number 1 button on this control. So this is kind of nice, because then you don't have to keep restarting the program. It's just going to come over to here, stop, you measure the thing, you make your adjustments, and then you push cycle start, and it's going to loop back in the program up to here and rerun the tool. And I kind of like this because it always approaches in the same way too, to the hole, which in my mind kind of makes better sense, because it takes out any kind of backlashes or errors in the machine coming up to the hole if it always approaches in the same direction. I think that works better. You know, in theory that doesn't matter on a CNC machine because it has compensation for such things, but holding this close a tolerance, I think that's better to do that in my mind anyway. So that's the program. And then after we get our hole to size, we'll push the block delete key, and then it'll go to the end of the tool and then stop. If we have optional stop, it'll stop on this M1 if we have that button depressed. So that's the program, the explanation. So we're going to run the tool, and then we're going to measure it to see where we are, and then make our adjustments. And then I'll show you what I normally do there. now that we've run the boring cycle one time, we're going to, you notice this coolant that sits on here? I put a post on Instagram about maybe machining some angles on here, or radius or something, so that this coolant wouldn't sit on here, because when I'm up here, you know, measuring stuff, this coolant gets all over the place. You can see right there. I shouldn't have left these areas flat on the top of this thing. But anyway, so now we run the boring cycle one time. I'll blow this off. What we want to do is take a measurement first. Now, I don't know if I showed this in the first video, but I set up this set of gauge blocks to the right size for my bore, and I've zeroed my indicator. This is set to the nominal dimension, or the middle of the tolerance here. And we're going to take a measurement here. So our zero was on the little needle on the first division, and the 0 point of the indicator. So we're 800, so we're 8 thousandths small right now, which would make sense because we backed off the head 2 revolutions, right? Which was 4 thousandths per revolution, so that's 8 thousandths. That looks pretty good. But now, I don't usually go the full amount. I like to work up on this a few, 2 or 3 cuts more. So I'm going to go half that amount. I'm going to adjust the head 1 revolution out for this cut. So we'll go over here. I don't know if you can see this or not from this location. And I'm just going to open this up one turn, or 4 more thousandths. And then we're going to rerun the boring cycle, and we're going to see where we're at. And I do this for a reason, because I want to take a cut, and then I want the cuts all to be the same, and I want to repeat the same thing over and over again every time I run this boring head, and this gives me consistency of what I'm trying to do here. So this cut should be 4 more thousandths bigger. Let's see what it ends up being. Looks like outside the window here of the machine. Now remember, I had the go-to statement, and so the boring head went up and back as if it was rerunning the tool the same as it started before, and it's just boring another pass. So it's repeating the same thing in the program, and it's going to go to this go-to statement and repeat it again, but it's going to stop first, of course. Let's just see what we're ending up with here. See, this is, well, let me move that thing. This is about 4 thousandths bigger, right? Just like what we thought it would be. But now, you would say, well, I could just adjust it out 4 more thousandths of an inch, and I'd be good. And that might be possible. But what I usually do is go out 3 more thousandths of an inch. So I take it within 1,000th of an inch of the finished size. 1, 2, 3 on the boring head over here, and then I run it 1 more time, and then we're going to see how close we are and make the final adjustment. 1/1000th of an inch more to come out. Which we do, maybe just a little bit more than 1/1000th. It's hard for me to see this. I'm looking around the camera here. Maybe 1.1 thousandths to come out. So we're gonna make our adjustment. Now, on this final adjustment, it usually cuts about 1/10 of a thousandth bigger than what you set. So I'm gonna go only 1/1000th of an inch, or maybe just even a hair less than 1/1000th, and run it again, and we'll see. It should come out pretty much to size. Finish is real good. On it, I just have to push cycle start, and it starts. And it has. This is a pretty big program, so it has to scroll through the whole program and come back up to it. That's why it takes a second or so for it to actually restart the tool. You might have noticed that it started the spindle and it sat there for just a little bit. We're going to run it for this should be the final time, and we should be out to our size. So it actually takes 4 times, I guess, total. The first time, and then 3 more cuts total to actually bring it out to size. But I do this on every hole just to be sure, because you can't ever tell. If you try to just run this thing and it cuts oversized, well, then the part is scrap. So it's not worth it to save just a few minutes. I'm going to rotate this around just in case I have to make an adjustment and run it again. Although I shouldn't, because I think this is the final cut. You see we're right on the dimension. So that's what I do to bring these bores out to size. I'm holding, you got to get it just right in here. I'm holding the tolerance this close. Although I could actually hold it closer than the actual tolerance, because I hit that right on the dimension. And now I run the second hole, which is this hole over here, just the same way on every part. I've been doing this in every part. I didn't really show that in the video. I thought it might be worth showing. And I do that the same every time. It's important to repeat the same depth of cuts. At least I believe it is. It's been very consistent. If I repeat the same depth of cuts, I back it off 2 revolutions or 8/1000ths of an inch, take a cut, take another cut 4/1000ths bigger, take another cut 3/1000ths bigger than that, so I'm 1/1000th undersized, and then I make my final adjustment. Now the final adjustment, actually, you don't bring it to the full amount, because the boring head takes just a little bit more than your adjustment on that final cut, on the 1/1000th of an inch cut. And so I usually leave it like 1/10 of a thousandth under where it should normally be, where you think it should be, and it cuts it right to size. The part out to size, and you notice it stopped on the MOO. Let me get this camera back just a little bit so you might be able to see this. On this now, I want to go over to the block skip soft key on this machine, and I push the block skip 1 button here. You notice this has 9 block skips or block deletes. So if you put the appropriate number after the slash, these buttons will control it by that number. which can be very handy for certain kinds of things. Now, see, we're setting right now at this line, and it will repeat over and over again, like I said earlier. But now that I push the block delete key, when I push cycle start, you'll see that it'll go beyond it. See how it skipped over it now because that block is deleted, and it's going over to the optional stop. And now I want to take off the block delete immediately because I'm using it on the next boring head, which is coming up. Put it in single block right now, and it's coming down, and now I can see it's down in front of the part here, in this case the next boring head. Then I can push this button and it stops the spindle, and I got to open the doors, but that takes 2 hands. And what I'm going to do here is do exactly the same thing as I did before. I'm going to back the boring head off, get the wrench. One, 2, and then go about half a revolution beyond and come back up to the number to take any backlash out of the boring head. And then we're going to run this one for the first time and repeat this exact same procedure. I used 2 different boring heads here because I didn't want to that long boring bar, I didn't want to have it on all these extensions like this. And this is just a shorter bar. This is just a regular steel bar here. And it seems to be working good, although I had to lower the RPM down to about 500 RPM with these long extensions to kill any kind of vibration on this setup. So I didn't want to run that longer bore at those lower speeds, if that makes any sense. So anyway, that's the boring procedure I go through to run these 2 holes, and it's pretty much the same thing I usually do with the boring head when I'm holding close tolerances on every hole that I bore like this. So what I do is I back the boring head off a certain amount. It depends on how much stock is in the hole and what I'm doing, and then I take a cut, and then I go half that amount bigger, which is what I just did, like you saw. And then when I measure that, I take an amount that gets me within about 1/1000th of an inch of the finished size, and I take that cut, and then I measure it, and I have to adjust whatever I determine is going to bring it to the final size. Now that does vary a little bit with what kind of material. With this aluminum, it cuts very consistent to the actual dimensions the boring head is adjusted to. With some kinds of materials like titanium and stainless, this works a little bit differently. But you have to kind of figure that out the first time you run the head, and then you just have to repeat that same exact process every time you run it on every part. I know this seems like it takes a lot of time, but it's very much better to spend the time and not screw up the part, in this case, with all this work already done on the parts. So I don't know if this is a help to anybody. If it is, I hope it's a help. And thanks for watching.